All right, well, that last video got a little long, so let's go ahead and break down our Webpack config that we have so far. So we have our CSS and Sass loaders up here, just straightforward loaders. You'll notice that I use this syntax, this style exclamation point CSS or style exclamation point CSS followed by Sass. That's how we combine loaders. Remember how I said that the style loader adds CSS to the website, the CSS loader loads CSS, and the Sass loader compiles Sass into CSS. So we have to create this pipeline. Now, the pipeline is actually backwards. It feels backwards. I feel like it should be CSS styled, because that makes more sense, reading left to right. But the way that the loaders are piped is it's right to left. So we start with CSS loader, then the style loader. So that's what's going on up here with our CSS and Sass loaders. And then this guy right here, what he's going to do is he's going to allow us to load in any of those files, but he's going to load them in just as straight up files, or he's going to load them in as URL encoded files right into our CSS. So let's take a look at what was outputted. If I go up to public build, notice how I have this crazy blah, 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 dot .png, and then I have this application.js. Let's look at application.js first. If we scroll down, we will see that I don't think we quite got a development build here, unfortunately. But you'll notice we have a bunch of this stuff. This is all the CSS loader and all that fun stuff. And here's our CSS. It's right here. And check this out. The background is set to URL of Webpack require module 6. So what does Webpack require module 6? Well, if we take a look at it, there's module 5, there's module 6. Webpack require module 6 is simply a reference to that file. So it mangled the file name and it copied it over, which is awesome. So we can include any of these files in our JavaScript or in our CSS or in our Sass. And Webpack will just copy it over and it'll correct the file names for us. And what's awesome about it using a hash right here is it'll do cache busting, where if this file doesn't change, the browser won't re-download it if the user goes back to your website, because the file name will change only if the file contents change. Let's go ahead and talk about what would happen on this URL loader if I said maybe limit was 5,000. And let's rebuild it and let's see what happens. If I rebuild it, how big is that file? Let's just make it huge. I don't want to do math right now. All right, we built again. Check this out. Now that I set the URL loader to a really high limit, notice only one thing was built. And if I jump into my application.js, check that out. Our module 6 is no longer a reference to a file. It is now base64 encoded of that image in a URL. So now it's been inlined into that file. Now, why is that important? Well, it's important because sometimes we have a bunch of really small. So let's move this back down to 512 or 10024. So if it's under a kilobyte, we don't want to force the browser to go out and request another file. Instead, we can inline that file right into our CSS. And it does this all for us automatically. And by doing that, we save a whole web request, which web requests are very slow. So that's what the URL loader does. The URL loader will check to see if it's greater or smaller than that limit. And if it's greater, it'll instead use the file loader. But we can use the URL loader and the file loader to load things like anything you want. JSON files, we can use them to load sounds, music, anything we want. And that's really awesome, I think, anyway. All right, I do believe we have a bit of a bug here. I don't see any eval source maps, or maybe I'm just blind because there's all that other nonsense. All this stuff that was added in is the style loader that was needed to be added in. I don't see any eval source maps, so I think I messed up my config. So let's talk about eval source maps for a second. No, it should be eval source maps. So let's try to find actual source code. Let's try to find this call to ble instead of our built application. So I'm just going to search for it. And no, it's not using eval source maps. Oh, that's because I'm an idiot. It's dev tool with the lowercase t, not capital T. I can't believe I missed that. So remember, make sure your dev tool is lowercase t. So our code was working, it's just I missed the property, which happens a lot with Webpack config. Just get used to it. It's worth it. It's crazy and insane, but it's worth it. All right, now let's open up Application.js, and wow, what is that? This is what happens when you use eval source maps. So all of the modules are included as being wrapped by eval, and then the source map is appended right after that. Why is this important? Well, it's important because if this file changes, the source maps need to be updated, right? So if you make one tiny little change in one file, the entire source map has to be rebuilt. But if we use eval source maps, only this bit cares about the source map, because the source map is local to that one module. So this is how we have multiple source maps, quote unquote, which we do, I guess, but they're embedded into each module as opposed to being an external file. That's why they're so much faster, because the source map does not have to be rebuilt every time one line of code changes. So that's why we prefer them, but we do not prefer them for production. Doing this for production would be bad. Please don't use this in production. All right, let's solve a very common problem. So let's say I come up here and let's say I want my client to use jQuery. We're going to be using jQuery because why not? So I'm going to npm install jQuery -- save, right? So now jQuery is available to both our client and our server. Remember, Webpack can compile node modules. So installing jQuery as a node module provides it to our client. So we've installed jQuery. Now in our application.js, let's say at the top here, we say import money from jQuery, right? And then let's say money body HTML low. So we replace all of the HTML content of the body element with this one string, which is a silly thing to do, but it makes ESLint shut up. So what do you think will happen when we compile this? Let's go ahead and do that. Remember, it's bin node modules .bin webpack config webpack client. What do you think happens? Well, let's look at our build. Our build is now huge. We have this one thing right here. This is jQuery. Right here. Huge thing of jQuery right here. And that's going to slow us down in a lot of ways when we do our watching, our incremental builds. It can also slow down the client. Like, for example, in a production build, we should be able to cache all of our vendor scripts and only have to re-download the client code if it changed. So how do we pull jQuery out of application.js? Well, it's actually very easy to do. Let's jump back into webpack.client, and I just have to modify 2 lines of code. Well, actually, I'm going to do 3. At the top, I'm going to write a const called vendor scripts, or how about vendor modules? And I'm going to say vendor modules equals a array of strings, and we're just going to do jQuery for now. Then on plugins, remember, plugins is an array that's also included at the bottom of the file. Now for plugins, I'm going to say new webpack.optimize.common chunk plugin, passing in vendor and then passing in vendor.js. So what are these? We don't have webpack required in yet. Let's do that first. At the top, do webpack equals require webpack. See, that's why I love ESLint. I wouldn't have noticed that webpack wasn't included in if I didn't have ESLint running, and then I would have looked like an idiot. So pull in, instantiate a new webpack optimize common chunks plugin. And what it does is it'll take anything in a entry point called vendor, any modules in that entry point, and it'll stuff it into a file called vendor.js, and it'll extract it from our primary build. So now all we have to do is create an entry point called vendor. So we come down here to the way I had entry set up before. Remember I said we were adding another entry point. And I'm going to say vendor is vendor modules. So basically, I'm just saying vendor equals an array of strings and call jQuery. So what's going to do is it's going to pull down the jQuery module, put it into this vendor chunk, but then the common chunk plugin is going to make it so that that vendor module only exists in this one entry and does not exist in this entry. Yes, that does mean that we have to now require 2 scripts on our page, our vendor and our application, but that's totally fine. So now if we come over here and run our Webpack, we'll get an error. And the reason is I probably misspelled something. So we want webpack.optimize.common chunk plugin. I hope I spelled it right that time. I did not. That's because it's called Commons Chunk Plugin. What an awkward name, Commons Chunk Plugin. I speed read, so I always thought it was called Common Chunk Plugin for some reason. I don't know. Whatever. Now run this again. So remember to add that S. I messed up. All right, so immediately we can see it worked. We see our vendor.js is now 748 kilobytes, which is pretty big, but that's jQuery for you. And our application.js is now 33.2 kilobytes. So now, instead of being 779 kilobytes, it's only 27.5 kilobytes. And if we look in public build and we refresh, we now see vendor.js right there. And we can do this for as many packages as we want. Let's say we need Lodash. We can npm install Lodash save dev. And now, if I were to require Lodash in my application.js, so, import from Lodash, and then to get ESLint to shut up, I'm just going to console log out _. And then now if we go to our webpack.client, all we have to do is come up to here to our vendor modules and say Lodash. Now let's rebuild. And our application should stay roughly the same size, which it does, just a tiny bit bigger. And our vendor just got hugified. Wow, 2.03 megabytes. Lodash is huge. But there are ways with Lodash to only require what you want. If you're interested in that sort of thing, there's documentation on the website. But yeah, 2 megs is pretty big for 2 vendor scripts. All right, let's go ahead and do our production build. So for the production build, we're actually going to do this from Gulp. I'm not going to have a development build for the server because we don't need it. Or for the client, because we don't need it. We're going to be building the development client from the server, which is a weird thing to think about, but I promise it'll make sense, and I promise it'll be amazing. But let's come down here, and let's do our prod client. So for this, I'm going to copy and paste this line here, and I'm going to say private client tasks. I do have to import my client config, so I'm going to import create as create client config from webpack.client. And then for my private client tasks, I'm going to create a very familiar looking prod client build that takes in a callback. And I'm going to say const compiler equals webpack. And then we're going to say create client config, passing in false for the isDebug flag. And then I'm going to say compiler.run error stats goes into output webpack. How did we do that? We just, okay, prod client error stats, and then do our callback. And that's all we need to do to build our client. So let's go ahead and add a task for it. So I'm going to say gulp task. Actually, I'll do it underneath this. Gulp task prod client, which will gulp series on clean : client. That's fun to say. Prod client build. And I'm also going to do a gulp task called prod. And the prod task is going to say gulp series clean, followed by gulp parallel, prod server build, and prod client build. So it'll do the clean, which cleans both the client and the server, and then it'll do a prod server build and a prod client build. But let's go ahead and see what a production client build looks like. Wow, that wasn't expected. Okay, so now I can do gulp prod client, and maybe move this off to the side so you guys can see the code here. So we cleaned our client, and we built our client. So what does it look like now? If we open up public and refresh, we now have application.js, but we also have application.js.map. So this is a production quality source map. And this does not use eval. But notice it's not minified. So let's fix that. Let's make our production build minified. So jumping into our Webpack client, I'm going to say if not isDebug Then I'm going to say plugins.push. Remember, the plugins is the array of plugins that we're adding to Webpack. And the plugin we're pushing should not come as a surprise. And in fact, to avoid embarrassing myself with misspelling it, I'm just going to copy and paste it from our Webpack server. So it's going to be our plugins push new Webpack optimize Uglify.js plugin. So now let's run our prod client again. Now this is going to take a little bit longer, especially since it's going to be uglifying Lodash and jQuery. Uglify.js is not very fast. Okay, it didn't take as long as I expected it to, but still took 5 seconds longer. Anyway, if we come back here and open up our application.js, check that out. It's completely minified. And if we open up vendor.js, check that out. Both Lodash and jQuery are indeed minified. And VS Code gave up on trying to print out semantic errors. That's funny. So yeah, we have one more problem. The problem is our CSS is still inside of that JavaScript file, and I don't like that. I don't like that for production. For development, it's great. Oh, it's so awesome. When you see the hot dev middleware with the hot reloading, it's beautiful. But for production, it's not. For production, we want to load our CSS before our as early as possible. Sometimes we just want to load some CSS early as possible for above the fold content, and we could also do that here. But what I'm going to do with this is I'm going to make it so that when we do a production build, we get our own CSS file that is extracted from our JavaScript file, so that all of our CSS is loaded in our head element, but our body is still loaded, or our script is still loaded in our body element. All right, can any of you guess what the first step of doing this is? If you answered installing another npm package, you'd be correct. So we're going to do npm install -- save dev, because we only need this for development. We only need this production package for development. Well, it's true. We only need it for the build step. Extract, this is an awful name, extract -text -webpack -plugin. Very long name for that, but it'll allow us to extract our CSS into a CSS file, and it's going to be an awesome thing. So give that a sec to install, and it did. And since we grabbed a module, we need to include it at the top. And since this is a class, I'm going to start off with an uppercase. Extract text plugin equals require, and we have to type in that awful thing again. Extract -text -webpack -plugin. And now we can use this plugin for our non-development builds. So what I'm going to do is after we do our Uglify.js, I'm going to say plugins.push new extract text plugin. And then what I'm going to do is I'm going to pass in name.css. Then I'm going to do something crazy. I am going to rewrite our CSS loader's loader. So I'm going to say CSS loader.loader equals extract text plugin.extract style CSS. And then I'm going to say Sass loader.loader equals extract text plugin extract style CSS Sass. So this is why I aliased out my CSS loader and Sass loader up to the top, because I modify their loader when we're in production. And the way I modify them is using the extract text plugin. Basically, I'm saying, hey, go ahead and if you see something from this loader, extract it into text. That's probably why it's called the extract text plugin. And then when we push it into our plugins array, we can specify the options. And in this case, what we're doing is we're saying extract the CSS and stuff it into a file that is the name of the chunk that you extracted it from. So let's say the vendor entry point had CSS, then we would get a vendor.css. But since it doesn't, all we're going to get is an application.css with all the CSS that we added into it. But with that out of the way, whoops, I do not want to install that twice. With that out of the way, let's go ahead and gulp prod client. And I'll pause because this might take a second. All right, it seemed to have worked. Let's see if our extract text plugin worked. So let's open public build and check that out. Isn't that awesome? Not only do we get a application CSS with all of the CSS of our application extracted out, but we also get an application CSS map. So our source map's propagated all the way from Sass into JavaScript and then was extracted into its own file. So it's not a trivial process, but it's brilliant for production builds. And as I hope you're starting to see, Webpack is an extraordinarily powerful tool. Just don't let the configuration options scare you away. And with that, I think that wraps up this video, and we'll see you guys in the next one.